Hello everyone, my name is Monit and in today's session we will start paper 4 of A-level structure question of October-November 2020. Paper code is 41. Before starting, please read all the instructions and the information provided. We can use the datas and the formula for solving the numericals. Let us start with the very first question. What is meant by a field of force? So a region or space where a particle can experiences a force, that is known as a field of force. For example, electric field or gravitational field. Look, it is of 2 marks, so the main keywords are the region or the space where a particle can experiences a force. Also, you can add some examples like electric field or the gravitational field are the forces which are under the category of field forces. Now the second part, define gravitational field strength. So the gravitational field strength at a given point is defined as the force per unit mass. It is of 1 mark. Mathematically, it can be represented as G defines the gravitational field strength, that is the force per unit mass. So the keywords are force per unit mass is defined as the gravitational field strength at a given point. Now the B part is a numerical. It is saying an isolated planet may be assumed to be of uniform sphere of radius, this with its mass as this, concentrated at its center. Calculate the gravitational field strength of the planet. So we know that what is the gravitational field strength, that is G equals to Gm upon R square. The capital G is the universal gravitational constant, which is 6.67 into 10 raised to power minus 11, and this is 6.42 into 10 raised to power 23, that is the mass given to us, and the radius is 3.39 into 10 raised to power 6 whole square. So putting up the values, we get 3.726, rounding off into 3 SF, that is, and the question it is given that the values of radius and mass is 3 significant figure. So we get G equals to 3.73 Newton per kg. So it is of 3 marks, 1 mark for the correct formula, 1 mark for correct substitution, and 1 mark for correct answer in correct significant figures. Now in the C part, you can see, calculate the height above the surface of the planet as we calculated in B, at which the gravitational field strength is 1% less than its value at the surface of the planet. So right now we are supposed to calculate the height above the surface of the planet where the gravitational field strength decreases by 1%. So I can say that is 99% of the present value which we have calculated in the B part. So that will be equals to Gm upon R dash, that is the new radius, or you can say the from the center of the planet to the point where the gravitational field strength is less than 1%. So calculating the value for R dash, we get 3.41 into 10 raised to power 6 meter. So the height we are supposed to calculate from the surface of the planet. So this is the total distance, and then we are subtract with the radius of the planet, so to get out the height from the surface of the planet. So getting a difference of R dash and R, we get 2 into 10 raised to power 4 meter, which is our answer. So it is of 3 marks. So you can see here 1 mark for the correct substitution of values, 1 mark for calculating the R dash, and 1 mark for the calculating the height. So this is constitute of the question number 1. Now the second question. The first law of thermodynamics may be expressed as delta U, that is the increase in internal energy, plus Q plus W. State the meaning of plus Q and plus W. So the plus Q stands for the amount of thermal energy transferred to the system, whereas the plus W stands for work done on the system. Okay, so this is of 2 marks. So that these are the only keywords: amount of thermal energy transfer, and that is the work done on the system. Now in the B part, there is a graph or the variation of pressure P of the volume V of a fixed mass of an ideal gas is shown. The pressure is on the x-axis and volume is on the y-axis. This is A, B and C. The gas undergoes a cycle of change from A to B, then B to C and then C to A. During the change from A to B, the volume of the gas increases. You can see here from A to B, the volume is changing from 2.3 to 3.8. Show that the magnitude of the work done during the change from A to B is 390 joule. We have to show. Also it is mentioned from A to B there is a constant pressure, so the work done will be equals to pressure times change in volume, that is P delta V. So the pressure which is remaining constant, that we can find out, which is from A to B, is 2.6 into 10 raised to power 5 times change in volume, that is the final volume minus initial volume, into 10 raised to power minus 3. So we calculate and we get 390 joule, that is of 1 mark. So applying the formula and showing it is of 1 mark. Now in the next part, state and explain the total change, if any, in the internal energy of the gas during one complete cycle. So you can see here in the graph, it is started from point A, then it goes to B, then C and then again C to A. So the initial and the final conditions are the same. So there will be no net change in the internal energy as the gas returned to its original temperature after one complete cycle. So this is of 2 marks. So one is for no change and the one is for reasoning, explaining that gas returned to its original temperature after one complete cycle. Now in the C part, and the most important one as well, during the change from A to B, there is 1070 joule of thermal energy transferred to the gas. And during the change from B to C, no thermal energy enters or leaves the gas. The work done on the gas is 550 joule. Now use these data and the information in the B which we have calculated to complete the table 2.1. So this is the change from A to B. It is mentioned that the thermal energy, that is the Q, that is transferred to the gas, so it will be plus 1370 joule. Now in the initial from A to B, it is shown that the magnitude of the work done during the change, that is 390 joule. Now here comes an important concept, that whenever the gas is expanding, please remember student, whenever the gas is expanding, the sign for the work done on the gas is always taken as negative. So I will write it down here. You can also write it down. The work done for expansion, if the gas is expanding, we are taking as a gas as a system, so work done for expansion is taken as negative sign. Similarly, the work done for compression, if the gas is getting compressed, then it will be positive. Okay, similarly you can see here from A to B, it is given in the question, that is it is 1070 joule. So we have taken 1070 joule. Work done as it is expanding, so I have taken negative sign, so minus 390. Now using the first law that is given in the question, using this expression, you can find out the value of change in internal energy, that is delta U. So by using these, we have calculated that it is the change in internal energy 980 joule. So for A to B, we have completed the complete table. Now from B to C, if you see the graph from B to C, also in the question it is given no thermal energy enters or leaves the gas. So there is no transfer of thermal energy, so it is 0. Q is 0 for B to C. Now the work done and the change in internal energy. Now the work done on the gas during this change. On the gas, it means it is showing on the gas is compression. And by the gas is expansion. So work done on the gas is compression. So we have taken work done as positive, that is plus 550 joule. Similarly, delta U, using the same expression of the first law of thermodynamics, it also comes out to be 550 joule, because the equation has to be uphold true. Right hand side will be equals to the left hand side. Now from C to A, now this is very important. From C to A, if you see the graph, from C to A, the volume is not changing. So if the volume is not changing, and we know that work done is equals to change in volume, and there is no change in volume, it means there is no work done. Okay, so there is no work done and the pressure is decreasing. So work done is 0. Now how do we calculate this Q and delta U? So for calculating the Q and the delta U, we know that the total change, we have seen here in the second part that the total change is 0. So the total change, if it is 0, then delta U for A to B and from B to C will get add up, and this comes out to be 1530. So this is in positive. So the same internal energy has to be decreased, because there is no net change in internal energy. It is somehow to be 0. So it has to be in negative. So if delta U is in negative, so Q is also in negative. It means the heat is being, or the thermal energy is being radiated outside. So we get minus 1530 joule as change in internal energy from C to A, and Q also minus 1530 joule, because the work done is 0. So I hope now the question number 2 is quite clear to you. In case of any doubt, you can comment in the video comment box. Okay. Okay, now the question number 3. A pendulum consists of metal sphere P from a fixed point by means of a thread. As shown, the center of gravity of sphere P is at a distance of L from the fixed point. The sphere is pulled to one side and then released so that it oscillates. The sphere may be assumed to oscillate with SHM. So the first part is, what is meant by SHM? So we have to define the simple harmonic motion. So this is a type of motion in which the acceleration of the object is directly proportional to displacement, and acceleration is in opposite direction to the displacement. Such type of motion is said to be as SHM, or you can say as acceleration is directly proportional to the minus of x, that is the displacement. Minus stands for the direction is opposite, and it is directly proportional. Acceleration is directly proportional to the displacement. So this is of 2 marks. So the main keywords are the acceleration of the object is directly proportional to displacement, and it is in opposite direction to the displacement. Okay. Now the B part, the variation of the velocity of V of sphere P with the displacement x from its mean position is shown. This is the black colored ellipse you can see here. Use this figure to determine the frequency of the oscillation of sphere P. Now we are supposed to find out the frequency of the sphere P. So we have the relation of velocity. It is given in your formula sheet in the question paper itself. So using this, we can find out the frequency. How? At x equals to 0, that is at the mean position, I can find out the value for V, which comes out to be, you can see here from the graph, at mean position the value is 0.25. That is the midpoint. You can see here it is 0.2 here, and it is 0.3 here. So this is the midpoint. So I can say this is nothing but 0.25 meter per second. So using this equation, at x equals to 0, this gets 0, x naught square under root, it is x naught. So we get relation V equals to omega x naught. omega using in terms of frequency is 2 pi f. So at x equals to 0, that is the mean position, v is 0.25, omega 2 pi f, and x naught at the same time, x naught is nothing but, that is the amplitude, or you can say the maximum displacement. So it can be this point. So this is 8, this is 10. So these are the interval of 4. So 8.8, that is the x naught, that is the maximum displacement, or you can say the amplitude, and in 10 raised to power minus 2. So putting up the values and calculating, converting into two significant figures, because you can see here the values are in two significant figures, or you can give up to 3. So the frequency comes out to be 0.45 Hertz. So 3 marks, 1 marks for the correct formula use, 1 mark for the relation and correct substitution, and 1 mark for the correct answer. Okay, now the C part. The time period of the oscillation is given by the relation 2 pi under root L by G, where G is the acceleration of free fall. Use your answer in the B to determine the length L of the simple pendulum. So we know that the relation between time period and frequency is inversely proportional. So using this and putting up the values, G as 9.81, we get the value of length, that is 1.2 meter. Now in the D part, and another pendulum of sphere Q suspended by a thread. The sphere P and Q are identical. This thread attached to Q is longer than the thread attached to the sphere P. This is the important point here. That is, the length of the Q is longer than the length of P, the thread length. The sphere Q is displaced and then released. The oscillation of Q have same amplitude as the oscillation of sphere P. Amplitude means the maximum displacement is the same. Sketch the variation of the velocity with displacement x for sphere Q. So we are supposed to sketch the variation of the velocity with displacement x for sphere Q. So we know that as the length for the sphere Q increases, so using this relation, if the length increases, the time period also increases. Now if the time period increases, the frequency decreases, and if the frequency decreases, then the velocity will also decrease. So the velocity will be lower than the drawn in the question. It will be lower than. You can draw any of the ellipse with the same amplitude. You can draw this also, or you can draw the one which I have drawn here for the answer. Okay, so this will be the right answer for the last part, D. So the question number 2 is completed. Now question number 4. Explain the principles of the generation of ultrasound wave for use in medical diagnosis. So we are supposed to answer the principle of the generation of ultrasound which is used for medical purpose. So we know that an alternating potential difference is applied across a piezoelectric crystal, causing it to change its shape. And this alternating PD causes the crystal to vibrate and produces the ultrasound waves. Therefore, the resonance occurs when the crystal vibrates at the frequency of the alternating potential difference. The one which we are providing the potential difference will also, because it is of alternating nature, so it will have its own frequency that matches with the crystal's frequency. Then the resonance occurs, and the natural frequency of the crystals is lying in the range of ultrasound. This received signal can then be processed and used for medical diagnosis. So this is of 4 marks. So the keywords which are used is the potential difference is applied across the piezoelectric crystal, causing its shape and the crystal to vibrate and produce ultrasound. Resonance occurs, that is the condition you have to show, which lies in the ultrasound range, and this received signal processed and used for diagnosis and medical. Okay. Now the next question. The linear attenuation absorption coefficient for a parallel beam of ultrasound wave in air is 1.2 per centimeter, and the parallel beam passes through a layer of air thickness is 3.5 centimeter. Calculate the ratio, that too in decibel, that is the intensity of beam after passing through the layer of air. That is, we know the relation is I equals to I naught is the initial intensity, E minus, that is the linear absorption coefficient, and X is the thickness over which it is passing through. So using the same, as the units are in centimeter only, so no need to change, directly putting up the values. So we have to find out the ratio. So intensity after passing, that will be I, and entering, that is the initial, that will be I naught. So I upon I naught is equals to E raised to power minus nu. Nu is 1.2. This is nothing but the nu, and this is X. So putting up the values, we get 0.01499. So for converting it in ratio in decibel, so for converting the ratio in decibel, you should remember one thing. If the students are unaware how to calculate the ratio in decimal, you should have one point, remember always, that the thickness of sound, or you can say the intensity, not the thickness, the intensity of sound in decibel is 10 times of log base 10 of the ratio I by I naught. So I have used the same. The ratio of I by I naught is already 0.01. So converting into the significant figures, 0.015. So I get minus 18.23. So rounding off into two significant figure, as per the question, you can see there are two significant figures. So the answer is minus 18. So this is of 4 marks. So 1 mark for the formula, correct formula, 1 mark for calculating the ratio, and 2 marks for converting the ratio into decibel using this formula, and 1 mark for the final answer. So 1 marks here, 1 mark here, 1 mark here, and 1 mark final. Okay. Now the next question, number 5. The simple one, define electric potential at a point. So we have learned that work done in bringing a unit positive charge from infinity to a given point, that is known as electric potential. That is, you can say V is equals to work done per unit charge. That is, Q stands for charge worked from infinity to a given point. So these are the keywords. If bringing a unit positive charge, that is work done from infinity to a given point. Now the B part, there are two charges A and B. They are separated by a distance of 12 centimeter in a vacuum. The charge A, the magnitude is plus 2 into 10 raised to power minus 9 coulomb. A point P lies on the line joining A to B, and its distance from charge A is x. The variation with distance x of the electric potential V at a point P is shown in figure 5.2. So this is the figure, that is the variation of electric potential from A to from this charge to this charge along the straight line. Now the question is asking the charge of B. How we will be able to calculate the magnitude, or you can say the charge or the nature of charge B as well as the magnitude. So you can see here the graph is cutting the x-axis at 4. It means the potential at a distance 4 centimeter is 0. So I can say at x equals to 4 centimeter, the potential difference is 0. So that potential at point P will be due to the charge A. This is the potential. We know the formula for potential, that is 1 upon 4 pi epsilon naught Q by R. So Q is already given for the charge A, 1 upon 4 pi epsilon naught, that is the permittivity constant, that is already given in the data sheet, and R in meter we have calculated for point P from A. Similarly, it will the total distance is 12, so it will be 8 from the charge B. The Q we are supposed to calculate, and this value is equals to 0. So by putting up the values and calculating for value of Q, we get minus of 4 into 10 raised to power minus 9 coulomb. Okay. So the answer is minus 4 into 10 raised to power minus 9 Coulomb. Similarly, now the next part, the change in electric potential when P moves from the position where x is equals to 9 centimeter to the position x equals to 3 centimeter. So from graph x at 9 we have potential difference of minus 10, and at x equals to 3 we have a potential difference of this is I think 2. Yes. So the final potential minus initial potential, 2 minus of minus 10 into 10 raised to power 2, because the values are in 10 raised to power 2. So putting up the values, we get the potential difference between the given positions are 1200 volt. That is the answer. Now in the C part, an alpha particle moves along the line joining point charges A and B, that is shown in the figure 5.1. Now an alpha particle moves from position 9 centimeter and just reaches the position where x is equals to 3 centimeter. Calculate the speed of v of the alpha particle at the position where x is equals to 9 cm. So we know that the speed or the kinetic energy is because of the potential difference applied. So the work done qv will be converted into the kinetic energy. So by calculating for v square, we have 2q, that is the charge of alpha particle, that is 2 times of charge of electron, that is 2e, into v that we have already calculated in the above part, that is 1200 volt, because the position from 9 and 3 are the same. So we have to use the answer of B second part. Now that is divided by half of mass of alpha particle, that is 4 times of mass of a proton. So 1.66 into 10 raised to power minus 27. Putting up the values, you will get your answer as 3.4 into 10 raised to power minus 5 meter per second. So this is your answer for your C part, that is their speed. So 1 mark for the correct relation, 1 mark for correct substitution of mass and the charge of alpha particle and the values other, and 1 mark for the correct answer. So this is your answer for C part. Now the next question, number 6. Define the capacitance of a parallel plate capacitor. That is the charge per unit potential difference. C is equals to Q by V, where Q is the charge on one plate, that is measured in Coulomb, and V is the potential difference across the plate, that is in volt. So this is of 2 mark, 1 mark for the definition, or you can say the formula expression and mentioning what is Q and what is V. State 3 functions of capacitor in electrical circuit. You can mention any other functions which are for which the capacitors are used in electric circuits. So it acts as a temporary power supply. It is also used for blocking DC, or you can say for converting AC into DC. It is used as an oscillator. It is also used for smoothing the AC current. I have written 4. You can write any of the 3. Now the B part, combined capacitance for terminal X and Y. We can see here these all are having the same capacitor of same capacitance. So these 3 are connected in series. So we know that 1 upon CS is equals to 1 upon 24 plus 1 upon 24 plus 1 upon 24. That gives you the combined resistance for the series part comes out to be 8 microfarad. Now for the parallel, 24 plus 8, that is 32 microfarad is the answer. That is the simpler one. You have to just use the formula for series and parallel for the capacitance. Now the 7th part. This is an important question. An ideal op-amp is used for a comparator circuit. Part of a comparator circuit is shown in figure 7. The one which I have shown with the blue color, that we are supposed to draw it. This is an incomplete circuit, so we are supposed to complete it. So it is mentioned that we are provided with 3 resistors of each having a resistance of 1000 ohm, and a negative temperature coefficient thermistor is also available. The circuit is to be designed so that at low temperature, this is the main point, that at low temperature the output should be minus 5 volt, and at higher temperature the output should be plus 5 volt. Now in the A part, the question is asking draw the input circuit to the inverting and non-inverting input of the op-amp. Inverting stands for negative and non-inverting stands for positive. This is of 4 marks. It is an important question. So we are provided with 3 resistors and 1 thermistor. So you can see here, these are the 1000 resistors which I have connected, and this is the thermistor. Use the correct symbols. Now how I have connected is, as you can see, for the negative temperature coefficient thermistor, if the temperature is increasing, so you have to remember, if the temperature is increasing, the resistance of the thermistor will decrease. Okay, so the question is saying at low temperature, it means if the temperature is low, the resistance will be high. Let us say this battery is of 200 volt. Okay, the input supply is 200 volt. So these are at 1000 and 1000. So the potential difference here will be 100 volt. The 100 will be dropped here. So this is at 0 volt. This is at 0 volt. Earthing is done. So it is at 0 volt. So the potential difference between the non-inverting input is 100 volt. Now for the inverting, at low temperature, what will happen? At low temperature, the resistance will be high. So there will be more resistance drop here, more than 100. So the remaining will be, let us say it will be, at low temperature the resistance will be high. So it will drop a more resistance. So it will be at 98. Sorry, this is thermistor na. So here the temperature resistance will be, temperature is low, so resistance will be high. If the resistance will be high, then there will be more voltage drop here. So there will be less voltage drop here. So it will be 100 and let us say 2, just for an example. So at according to the question, at low temperature the V out has to be negative. So if you do V plus minus V minus, so that is 100 minus 102, it will be minus 2. Now if we multiply with 10 raised to power 5, so it reaches a saturation point and we get minus 5 volt, which we are getting V out as minus 5 volt. This is just to check, because minus 2 into 10 raised to power 5, it cannot gain as more than the op-amp voltage. So it will get a negative saturation limit, that is minus 5 volt, and we are getting V out as minus 5 volt. Similarly, at a higher temperature, what will happen? The higher temperature, the resistance will be low, so less voltage will be dropped. So there will be no changes here for the non-inverting input. It will get 100 volt here. But when the temperature is high, the resistance is low. So if the resistance is low here, the less voltage will be dropped and the more voltage will be dropped here. So now we will get, instead of 102, we will get 98, let us say. So now we are doing, if V plus minus V minus, it will be 100 minus 98, which will be plus 2, and that we will get the positive saturation limit, that is we will get V out as plus 5 volt. Is it clear? So it satisfies this condition. This is the correct circuit diagram. Okay, so this is of 4 mark, 1 mark for the series in 2 resistors and 1 mark for series in 1 resistor and 1 thermistor. So, and 1 mark for correct, you can say connecting with the inverting and non-inverting input and the correct position of thermistor. So this is of 4 marks. I hope you have get a better understanding of this op-amp. Now state a suitable value for the thermistor resistance when the thermistor is at low temperature. So we know that at low temperature the resistance will be high, so it will be more than 1000 for getting minus 5 volt. So the thermistor is more than 1000. You can place any value. For my convenience, I have taken 1000 and 10 ohm, you can take any other value which should be greater than 1000 ohm. Similarly, for a higher temperature, the V out should be positive. So you have to take a resistance lower than 1000. So I have taken 990. So it will lie between any value from 0 to 1000 ohm for higher temperature. Okay. Now the question number 8. This is a conducting material having its phase as shown. This is a uniform magnetic flux density coming from this phase, and this is the direction of movement of electrons. The electrons enter the slide traveling perpendicular to this phase. For the free electrons moving in the slice, state the direction of the force on an electron due to the movement of the electron in the magnetic field. So we have to find out the direction of the force on an electron. So what we will use is the Fleming's left hand rule. So put your first finger in the direction of magnetic field. Now please be very careful, this is the electron given to us. So we have to take the direction which is opposite to the direction of motion of electron for the direction of current. Because in left hand rule, Fleming's left hand rule, the second finger is denoting the direction of conventional direction of current, which is taken as the opposite to the direction of movement of electron. So place your left hand in such a way the magnetic flux, that is the first finger, is in this direction, the second finger is in this direction. So you will find that the thumb is pointing in the downward direction. The thumb shows the direction of the force. So in the downward direction using Fleming's left hand rule. Now same, identify the phases using the letters between which a potential difference is developed. The phase PQRS, as you can see, the electrons are having a force in the downward direction, so the electron will be there. So the positive terminal will be of the opposite phase, that is PQRS will be the positive terminal, and the lower terminal, that is JKLM, will be the negative terminal. Okay. Now the B part, explain why the potential difference reaches a maximum value in the A second part. So due to the charge separation between the opposite phases, as the electrons are drifted towards the lower phase, that is JKLM, an electric field is created and a maximum value is reached when electric force is equal and opposite to the magnetic force on the electrons, because magnetic force is also acting and electric force is also acting. So a potential difference will reach a maximum value when they both are equal but in opposite direction. Okay. Now the C part, the number of free electrons per unit volume, that is N, given to us. The thickness is in mm. The magnetic flux is also given to us. Calculate the potential difference of the slice for a current of 6.3 into 10 raised to power minus 4 ampere. So this formula is already given in your formula sheet. Just you have to use up the values and putting the correct substitution of values. Convert the thickness, that is this, T, into meter. Rest all are in SI units. Just put up the values. You will get the hall voltage, that is 1.39, converting into two significant figure as per the question. You will get 1.4 into 10 raised to power minus 12 volt. You have to just put up the value. It is an easy question. Okay, now the D part. The slice in C is a metal. By reference to your answer in C, suggest why the Hall probes are usually made using a semiconductor rather than metal. So if you consider the formula, why we are considering semiconductor for making up Hall probes, the reason behind this is, for semiconductor have a much smaller value of N, that is the number of free electron per unit volume, that is this N. If this is less, then the Hall voltage will be more. Rest all is the other factor which can be controlled for both semiconductors as well as the metals. So that is the defining fact, that N is very small for semiconductors. That is why we have getting a semiconductor Hall voltage is larger than metal, so it can easily be measured. So that is the reason why semiconductor is used. So the keyword are have a much smaller value of N, so VH is larger than metal, so it can be easily measured. Okay. Now the question number 9, define magnetic flux. So the product of magnetic flux density into the area of cross section, and that should be perpendicular to the direction. So the formula is phi equals to B into A. Please mention that these are perpendicular to the direction, otherwise you will lose your marks. So it is of 2 marks. One is for product of magnetic flux density and cross sectional area, and 1 mark for showing they are both perpendicular to each other. Now it is a question of a simple transformer. These are given to you: soft iron core, primary coil, secondary coil, alternating potential difference. There is a sinusoidal, that is a AC current in the primary coil. Explain how this current give rise to an induced EMF in the secondary coil. That is, you have to explain the EMF induction, that is electromagnetic induction. The alternating current in the primary coil creates a changing magnetic field. Because the current is changing, so the magnetic flux will also change, which is in the core linking the magnetic flux with the secondary coil. If the magnetic flux is changing here, so the magnetic field linked with the secondary coil also changes. Thus, the magnetic flux in the secondary coil causes an induced EMF in the secondary coil. So this is of 3 marks. The keywords are: AC in the primary coil creates a changing magnetic flux that is linked with the secondary coil. So the changing magnetic flux causes an induced EMF in the secondary coil. Why the EMF induced in the secondary coil is not constant? Because the rate of change of magnetic flux is also not constant, because we are supplied with an AC current. So the rate of is also not constant, and induced EMF is directly proportional to the rate of change of flux that we have studied, and the Faraday's law, that the induced EMF is directly proportional to the rate of change of flux. How much fast you are changing the flux, that will be directly proportional how much induced EMF will be developed or produced or induced. Now the C part: explain why the soft iron core B is laminated. The laminated soft iron core reduces induced current in the core and hence reduces energy losses in the core. Then the efficiency of the transformer is increased. That is the eddy current only. What we are discussing is to reduce the eddy current, which reduces the energy loss. Thus the efficiency of the transformer can be increased. Okay. Now the question number 10, that is one of the common question. Briefly explain the principle of CT scanning. So you have to mention the principles, that is an X-ray tube. You can see here, no need to draw a diagram, I just give you a reference so that you can easily understood. An X-ray tube rotates around the stationary patient. A CT scanner takes X-ray images of the same slice at different angles. You can see here it will be rotated and it will take a image of same slide at different angles. The process is repeated and the image of successive slides are combined together. Then a computer images together to build a 3D image, and this 3D image can be rotated and viewed from different angles. So this is of 5 marks. So each point you can see consists of 1 mark. Okay. Now the next, this is one section and which is divided into 4 voxels K, L, M, N. The section is viewed in turn from 4 different angles: D1, D2, D3 and D4. So I will give you a small trick how to solve this question. Okay. So a detector reading for each direction are noted and these are summed to give up the values as shown in the figure. The background reading, this is important. The background reading is 24. Determine the pixel number KLMN as shown in figure 10.1. So we have to find out the values of K, L, M, N. So you can see these are the readings with the background reading. So what first step what we are supposed to do is subtract all the numbers with the background reading. So 42 minus 24, 45 minus 24, 30 minus 24 and 51 minus 24. After doing this, check in the figure how many rotations does this takes place. So this is the first, and then this is the first turn we have taken, this is the second turn, and then this is the third turn. So there are total 3 number of turns we have taken for this 2x2 voxel. So we have to divide it by number of turns we have taken. So if you divide it by number of turns, that is 3 by each, you will get 6, 7, 2, 9 Accordingly, the K stands for 6, 7 stands for L, 2 for M, and N for 9. So this is the right answer. So what you are supposed to do is, whatever the value given to you, first step is subtract by the background reading and then divide it by the number of turns. You will get your answer. Okay. Now the question number 11. A photon of a wavelength 540 nanometer collides with an isolated stationary electron as shown. So the deflected photon has a wavelength of 544 nanometer. The photon is deflected by the electron and this is given. What is mean by a photon? So a photon is a massless packet or a quantum of energy of electromagnetic radiation. This is of 2 marks. So 1 mark is of this is a packet or quantum of energy of electromagnetic radiation. That is the keywords. Draw an arrow to indicate the approximate direction of motion of the deflected electron. So just by considering the momentum conservation, if the deflected photon is giving in this direction, so the electron should deflect in this direction. This is not given in the question. I have drawn for the answer. That is the direction of deflected electron. Now calculate the momentum of the deflected photon. So that is the de Broglie wavelength. Lambda is equals to h upon p. H is the Planck constant. Value is given to you. P is the momentum we have to calculate, and lambda is the deflected photon wavelength that is already given to us in the question. Putting up the values and converted into 3 significant figure, you will get your answer. That is 1.22 into 10 raised to power minus 27 Newton second. Now the energy transferred to the deflected electron will be the difference of the incident energy of the photon minus deflected energy of the photon. That energy will be transferred to the electron. So by just we know that E is equals to hc by lambda. So using the wavelength of the incident photon and the deflected photon, you will get your answer in the joule, that is 2.71 into 10 raised to power minus 21 joule in 3 SF. So 1 mark for the formula and 1 mark for correct substitution and correct answer. Now the C part. Another photon of wavelength 540 nanometer collide with an isolated stationary electron. Explain why it is not possible for the deflected photon to have a wavelength less than 540 nanometer. Now as smaller wavelengths suggest greater photon energy, also after collision deflected photon loses energy, so it is not possible. Because if you are going for lesser wavelength, it suggests that you are having a higher energy of the photon, and we know that during collision some of the energy will be lost, so it is not possible. So this you have to explain why it is not possible. Okay. Now the question number 12. This is an iodine 131 is a radioactive isotope with a decay constant 9.9 into 10 raised to power minus 7 per second. What is mean by radioactivity? Radioactive, it is mean an unstable nucleus which emit ionizing radiation or decays spontaneously. So these are the keywords: unstable nucleus which emits or decays spontaneously. Next is your decay constant. The probability of decaying of nucleus per unit time is known as a decay constant, and this varies from nucleus to nucleus. Now in the B part, some water becomes contaminated with iodine. The activity of the iodine in 1 kg of water is 560 becquerel. That is the unit of activity. Determine the number of iodine atoms in 1 kg of water. So the lambda, that is the decay constant, is equals to activity upon the number of number of nucleus atoms that are supposed to be decayed. So N is equals to the number of iodine atoms in 1 kg of water, which is 560 divided by decay constant. So you will get 5.7 into 10 raised to power 8 number of iodine atom in 1 kg of water. Now the C part. The activity of 131 in 1 kg of water is to be less than 170 becquerel. Calculate the time in days for the activity of the contaminated water in B to be reduced to 170 becquerel. So using this is already given in your formula sheet in terms of x equals to x naught e raised to power minus lambda t. So using this activity, we are supposed to find out is 170. The initial is 560. Putting up the values for calculating t, you will get 1.204 into 10 raised to power 6 seconds. Converting into days, that is 13.93. Rounding off, that is 14 days. So here we have completed with all the complete solution of your 9702 41 October November 20. In case of any doubt, you can comment below. If you like it, please share and subscribe my channel. Please share with your friends as well so that they will also get the benefit. All the very best for your exam. Thank you.